Here we are. All right. So this was quite the week. It was like the week of every AI new announcement. There's so many announcements I don't even know where to start. It's been absolutely crazy, spectacular, amazing. I think we live for these types of weeks and in on the AI hackerspace. It's been nothing short of just astounding in terms of some of the tools that have come out from Google and others. I don't know where to start. Rob, how's it going?
Great, great. Yeah, it was epic. The VO3 video with sound, crazy stuff out of Google. And somehow in between it all, with the new tools, and all your clients, you still drop Spark Bench and some incredible new stuff. So I'm looking forward to this week. We got three guests. So Willie V3 is with us this week. And then Braun, our good old member, Braunfield Walker, he's got a new rapid audio to text conversion tool that he wants to show. And then Bensa and Mondweep are going to recap. We had the big London, UK event this week, and it was great success.
It was the week of Google, it would seem, and big thank you to Google London and Benson Manjuik for putting all that together, and
And
our friends
requesting.
at Requesty who
Yeah.
were critical in sort of the organization of it. I think London is going to be a really good spot for us for sure.
Yeah. So we'll see some pictures and get a little recap from those guys on that. So huge.
Yeah, for sure. And so, well, we've got a lot to cover today, and I think, in my opinion, Google won the week. Um, if you look at this, if you look at the stuff that was put out, not just BS, but real things you could try. Whether it was that Flow video system, which is just mind-boggling the way that they handle both audio and video and adjust it. I don't know if anyone's played with it, but the output that I'm getting from it is nothing short of spectacular. It's expensive, like yet another $250 thing you have to sign up for. I'm hoping, Martin, we can get a cheaper nonprofit version of the Google AI stuff. So, and Martin, by the way, thank you for setting up all these nonprofit things for us. We're getting lots of good deals. Actually, Martin, why don't you give us a quick overview of some of the nonprofit deals you've been able to spin up for us?
Yeah, so I guess the main one, GitHub was first. So we got the GitHub nonprofit account. Essentially, that allows us to add people to the organization without paying the $4 per person. That makes a huge difference for us. Second, the Google Workspace. So Google Workspace for domain, we were on business standard. That's like, I don't know, $17 a person, but we get several hundred, I can't remember the right number, users on the domain for free. And that's a really good basis point. And beyond that, we can actually take a subscribed version and get 72% off. Again, makes a huge difference for an organization like ours, where really it's volunteers that pile in that help us get things done and get the things done that you want done, right? Because you can basically put your actions where your heart is. Beyond that, we also now have a subscription to TechSoup. TechSoup and GoodStack, each of those provide gateways into multiple software partners. It's no secret, I used to work with Atlassian software, and they will give you 75% off for non-profits, which again, if you're using something like Loom, which is one-to-one video chatting, and they'll do the compression of chats that you can basically email back and forth, a little video conversation, that's a great enabler to mean that you don't have to be in the same room in order to have a meeting, because you can just basically swap ideas over these little videos. Things like Confluence, Jira Service Desk, all those sorts of things. So yeah, I mean, there's a lot in there. I will try and prepare a little summary next time and give you an update accordingly.
Well, I definitely appreciate all the hard work you've put into saving us quite a bit of money. So we get GitHub essentially for free, which is amazing, which includes code spaces and other capabilities. We're getting, you know, various cloud services. I think some of them are like 75% off for, you know, AI and related tools. So what we're going to try to do is figure out how we can get others in the organization to also take advantage of some of these nonprofit rates that we're able to get. Because I'm not going to lie, a big part of the reason for us to be a nonprofit was to get discounts on these tools that we use that are really expensive, especially if you're trying to do a benchmarking system or just trying everything under the sun. It really just adds up quickly. So really appreciate you putting the effort. And I know a lot of this was like a lot of busy work and back and forth with Google and whatever. So thanks for making that happen.
Sure.
Yeah, really appreciate that. So what else is going on this week? A lot. And let me just jump in. I'm going to give you a quick rundown of some of the stuff. I'm going to try not to go too long because we got a lot to cover. We got some really good people presenting and a lot of stuff to cover. So like always, if you have questions, feel free to pop those into the chat. I will try my best to keep an eye on that, but I'm going to go quick. So here we are. So let's start with like cost. I always like jumping into Requesty. I love Requesty. And I made a big mistake yesterday. And you'll see it right here. I managed to spend $225 of my own money, I might add, because I mistakenly used the Opus 4 model for my testing rather than using Sonnet 4. And a couple things to note. Avoid Opus 4 for right now. There's no prompt caching, or if there is, it sucks, as you can tell by my cost. So once I realized that, I just spent $224, I switched and removed Opus 4 from it. But look, if you look at the actual number here for a moment, you'll see that I used 42 million tokens yesterday. And today so far, which I've been really busy day building random stuff, I've used about 50 million tokens. The difference in cost is dramatic. Today I've spent $55 and I've saved 105, you know, in terms of context. And so to figure out where the issue was, I went in. I gotta figure. I think it was cost management, and then that allowed me to go and see the model details. And we go down here for a sec. Yeah, we'll see here the different models. So Opus 4 was the killer. And when we look here, you see I'm spending $1.29 per request versus Sonnet 4, 10 cents. And so my 93 requests ended up costing 120 bucks. So that's what killed me, essentially, I think. But what was interesting, I'm like, so once I realized that, you know, I'm like, why was Opus so much more expensive than Sonnet? Well, it turns out that you'll see here the cache rate is 0%. So that was like a spark in my brain that said, well, I need to be able to measure not only the performance of these systems, but the cost versus performance of these systems. And what if I could actually optimize the system both on both sort of dimensions of both prompt, cache, and other things, which then opened up the whole avenue of thinking, I don't know what you want to call it, that basically said, well, I need to be able to measure the effectiveness of these systems in something that's more than just me arbitrarily trying to do it. That's where I dreamt up this idea of a root code evaluation and benchmarking system. Now, when you look at some of the sort of numbers, like I think Martin shared a benchmark within the text chat for those interested on the Sonnet and Opus models. And one of the ones they're using is something called SWE benchmark. So the SWE benchmark essentially are, I think, around 2,000 or 3,000 random GitHub issues that you can go and test against. And now they give you that as a giant JSON file. Yeah, there it is. Thanks, Martin. And basically, what this does is allows you to sort of run it, test it, and see what the result is. And it's random. So when I thought, well, what if I can integrate that and create a specification? And this will do two things for me. One, I've been exploring this idea of long horizon, agentic development. These are things that run for more than several hours, right? And one of the problems I have with long running agentic processes is often they finish because it's hard to give an application and know that it's going to take you 36 hours to build. But when you have 3,000 different problems to solve, that can run for weeks, to be honest. So it's a nice way to have long running things, and it allows me to randomly test. That the second problem I ran into is I've yet to run this test and have it not be able to complete it, which I think is a good thing. So I'm literally running 100% on the test and the benchmarking, which is pretty amazing as well. So let me show you that quick. All right. So I went in here and I created this. You'll see how I've got an SQLite, and we got a database. We got two different databases I created. I parsed. So I'm using the SQL bench system, and you'll see there's data sets. These data sets, I'm not going to open this because they're huge, but these are basically JSON, which is terrible format to work within. So I converted the JSON to something a little easier to work with, which is SQLite. I was thinking of using DuckDB, but I ended up using SQLite. It's just easier. And you can see here that I've got the completion summary. I've got the various tasks. So these tasks essentially, let me make this a little easier for you guys to see. So these are basically random tasks, and I'm doing blind tests. I'm not giving the answer to the problem, which these also include both the problem set. So this would be like, here's the problem statement from GitHub, and then we have, here's the hints, giving you some details on what the problem is, or whoever submitted, saying how and what the problem is. Then we've got the the patch that was given to fix it, and other things to qualify it. But what I really want to know is tests to fail and tests to pass, right? So then what I can do is I can go in here and I have a whole variety of different tests I can run based on the Spark framework, and then includes AutoCure. Now, what's cool for this, beyond just the basic test, is I can use this to optimize my Spark protocol to do a test to see if I can improve the performance of the actual prompt itself. So it does it, maybe rather than taking 10 steps, I can get it down to 2 steps or 3 steps or 1 step maybe. I can also measure security and other various vectors like time, cost, and complexity, which is all the stuff that occurred to me when I saw a $225 bill the other day. So now I'm going to go back in here. So then I created as a mode. So for those who are familiar with my RU modes approach, I created a mode here called benchmark. And you can see here I've got different details on how the benchmark needs to work, problems to classify, what the SQL looks like, how to interact with it. I then created a number of different actual files to actually implement it. So you can see here I've got scripts that can do comparisons and the benchmarks. But I don't have to run all those scripts. That's a pain. So the RU actually does that when you go here. So now I choose the benchmarking orchestrator. So I make an orchestrator that basically is dedicated to that. Fingers crossed, it worked every time until I want to do a live demo. But I'm going to say run one random task. Let's just keep it, and let's see what happens. All right. So you can see I'm using Sonnet 4. And if all goes well, it should orchestrate a sub task. So it's going to figure itself out. There we go. It's going to look at some stuff, thinking. All right. Now it's going to switch to the code mode. It didn't do a subtask. I guess it doesn't really matter. I'm just asking it to do this mode. So I've actually updated the autocoder to be specifically relating to the benchmark. So you can see that it's now running the benchmark. So what this did is it actually is getting a task. So you can see here it ran the helper, and now it's randomly getting a task out of the thousands that exist within the SQLite. And then what it's going to do once it gets the task, it's going to say basically I'm starting the task. So it's another command. So what I'm doing is I'm integrating a combination of Python and benchmarking as part of the automated Spark flow. The reason I'm doing that is I'm not so much interested in I am interested in the benchmark and the cost, but I'm more interested in the optimization of the flow itself. So by doing this, I can recursively optimize the actual Spark system to say benchmark yourself, then optimize the actual rules and code based on the benchmark until you get a coherence. So what I'm looking for is to go from 10 steps down to something less, right? But at the end of the day, what's interesting about what you're looking at right now in terms of this benchmark is out of all the times I've run this, and I've run this probably 60, 70 times at this point, I've yet to find any problem in the more than 3,000 problems in the database that this system hasn't been able to solve, which means that using Spark, we're basically 100% capability, at least according to the SWE bench. Now, I need someone else other than me to take a look at it and find and poke holes into my benchmarking philosophy. But in terms of capability, we are now, if you believe this to be true, I think I do. It's a little early to go out there, but I'm going to use a bit of hyperbole here. We are at a phase where AI-based coding is at the level of any senior developer, without question. This is solving any problem I put at it. You could take this also, not just use this against the SWE bench. You could literally point this at any PR on GitHub or Jira or whatever and do it that way, and you'll get the same result. So here you can see that I'm getting my tests, so it automatically tests, it tests itself, all tests pass. And look, and within, it's cost 33 cents, which is, you know, not that expensive unless you run it 30,000 times. But it, again, nothing I point at it, you know, it can't be solved. So this is actually a really good way if you're looking at, you know, integrating this into your dev flow. You could actually take what I've done here in terms of the benchmarking and use it as part of a kind of project management flow. We could point it at different websites and kind of create like an angel bot where it goes and fixes all those issues you see in npm libraries, whatever. It's basically a self-fixing system that I built as a benchmarking tool, which is pretty cool. Now at the end, you can see here, so it's using a combination of, oh, it looks like this one failed. So let's see if it'll fix that problem. I need to fix the test function. Oh, it's always the test function failed. Okay. But anyway, moral story is it can fix anything and it just kind of works, and which is pretty cool. All right, that's one thing I built. I'm going to jump to the next thing. We can come back to that later. While we're on the topic of, and this is something I'm going to post this afternoon, you guys are going to get a little sneak peek of it. I hate RAG. RAG sucks. Retrieval augmented generation is probably the worst possible way to integrate data into an LLM. It's slow, it's cumbersome, it's really hard to update, and it doesn't work well with tools or MCPs. It's like it was built for an era that didn't have the concepts of function calling, tooling, or MCPs. So it occurred to me literally this morning while I was on my exercise bike, what would a retrieval system look like that was actually optimized for, you know, the current generation of LLMs, specifically cache, right? So these LLMs now have the ability to have prompt caching built directly into it. So prompt, as you saw earlier, prompt caching is what makes these systems really cheap and affordable and fast. So by prompt caching, I'm able to get substantially faster response times. And I built a benchmark, of course, to prove this process that allows me to use a kind of time to live. So I'm pinging the thing, giving it the data, and then extracting the data directly from the prompt cache in the LLM for things like Sonnet 4, as well as various things like you know, the latest OpenAI and stuff like that. So the architecture basically is similar to RAG, but I'm bypassing the need for any kind of vector, which again, vectors, because of the similarity search, have a tendency to not give you the right response. So this is explicit. Then I can call a tool registry, MCPs or other sort of tooling, and then process directly that into a sort of data structure, both local, like a SQLite or DuckDB or whatever, as well as injecting that directly into the caching mechanism of the LLM, which is substantially faster. So the benefits to that include, in my initial tests, which I'm going to go here and show you. So let's go to my next one. So I ran this just before the call this morning. I did a quick test. I was able to get a 91% cost reduction versus RAG, 91%. So the problem with RAG is the data has to be inserted every time, which causes differences in the prompt. Because it's a similarity, those differences mean that it's hard to cache because there's minor inconsistencies in it, and it just doesn't work as well. And I was able to go from a 3x or a 320% increase or decrease in latency in terms of speed. So I went from 160 milliseconds down to like 20 milliseconds and I was able to save 91%. And the other benefit here is I've got the ability now to integrate any MCP as part of the RAG process, both locally using Studio as well as remotely using any MCP that exists on the internet. So anyway, I'm calling it fact because it kind of works. And I'm gonna do a blog post later this afternoon about this. You guys can try it if you want. Again, like everything, I created a benchmarking. You can see this was entirely built between me getting on my exercise bike at 8:30 this morning and now. So there's quite a bit of stuff here. You can see here that, like, here the structure of the folders and all the components that's built. It's substantial. Zero shot, like Sonnet 4 for building complicated things is spectacular might not be the right word. It's phenomenal. Anyway, you can see here, this is how I built it. And here's my docs. You can see my initial planning. So basically, I started with basically a README. This is the sort of, here's what I want to build. Here, and I wanted to try the new arcade dev system, which is really a cool system. So you can see how that works. Where the heck, what's that image? I don't even know what that even is, but it looks like you inserted a weird image. Anyway, you can get a feel for it. Check out the scripts folder if you want to see all the little benchmarking. Here's the benchmark README. I think on my exercise bike in a matter of 3 hours, we reinvented the idea of RAG. All right, I'm done. That was me going at super speed here this morning.
How does the cache get injected into the model?
I'm using two approaches right now. I can do direct request of the MCP, which induces significant latency depending on whether it's local or remote. Studio would be faster, but for the actual benchmarking, I'm using SQLite. So I'm taking the data as a separate process running independently of the actual request. So I generally know what information, or I can show you guys quickly what that looks like. And let's go back just a quick. And again, I'm trying to. This is a art of the possible sort of thing, by the way. I don't know. And I looked around. I couldn't find anyone doing anything quite like it. So let's just go here. I'll show you what the data looks like. There we go. So in this case, we have a folder called Fact Demo, and this is a SQLite. So let's look at what the data looks like. So I'm inserting the data into a sort of a persistent structure. So then in this case, I did financial records, just as a good example. So these are like test companies. Then these are the records. So these would be data relating to it, just simple quarterly data. And then I've got a sequence that basically just tells you the results. I'm using this in place of what would normally be a vector. And I'm essentially running structured SQL as part of the RAG process itself, rather than like a vector similarity search, and which is here. Let's go back to the diagram which illustrates it. Here we go. Where is? Yep, here we go. So it's this layer here in the middle. So then I'm passing the information from the database to a prompt cache, and that's what gives it the speed.
Cool. So you're using the caching API of the LLM vendor to inject it?
Yes, exactly what I'm doing. And then I'm using TLS and pinging it every now to keep it live, and then I'm having multiple concurrent prompt caches running. And then this works best for things at scale where you were trying to save money, because you're doing a lot of the same sort of stuff. Let's say you have like a finance bot or something, and people are asking what their latest stock portfolio looks like or whatever, and then I'm just keeping that cached. Or so if you're working at scale, 33 cents adds up quite quickly.
So what happens? What happens if somebody asks a question that's not in the cache?
It will then make it in the same way that you instantiate the tools. It'll make the request, update the cache, and subsequently anyone else that makes that request will then get that if they're approved. That is. So you can. It's all the same general concepts of a sort of RAG style approach without the vector. So I'm
using as a key for the cache.
Sorry.
Prompt.
It's prompt. Yeah, it's data. I'm just static data. I'm just injecting the data directly in the prompt. I'm using the prompt cache.
So you're saying that you take that entire SQLite database and you dump that into the cache and then flooded that into the cache of the model.
Yeah, and then
Okay.
every subsequent request at that point is free.
Yeah, because you overloaded the model's token cache with the entire database of data.
And then if it's beyond the 200K limit, I just chunk it into multiple prompt caches.
Okay, yeah. So this is a known strategy where model vendors say, yeah, just put all your data. We have a million token cache or 2 million token, context window. So just dump all your data into the token context.
Yeah, sort of, but because it's cached, it's not doing the context interpretation. It's doing because I'm predetermining the output because it's cache. So what the issue you have with prompt stuffing is you get the U-shaped issue with the interpretation of the data. I'm doing zero interpretation. I'm giving it explicit deterministic response. That's what the cache does, right? I know exactly what the response is going to be. I've explicitly told it and then measured it. So there's no variance like you do with RAG. With RAG, you can insert the data 10 times and get 10 different variants on the output. There is no variance.
That is true with RAG. There's a major problem with duplication, and you have to go through a lot of. The more you deduplicate the data, the higher your answer performance or your retrieval performance.
Exactly. And in this scenario, I know exactly what the output's going to be, and I can measure it. It's because it's deterministic. I don't want any variance on a RAG-based system. And that's the biggest issue with RAG is both speed. It's generally pretty slow. Even the most optimized systems are pretty slow. And there's always this kind of variance in the output. No matter how much you try to make it not vary, there's always slight variance. And for certain applications, especially things that involve numbers, mathematics, and code, there's no room for variation. This solves that problem.
True, because RAG is a semantic search, not a deterministic search.
Mm-hmm. So this works really well for MCPs.
I'm sorry. How do you predetermine you say by predetermining you know what is going to be asked?
Well, I know what's going to be asked, and then I also know what's going to be output, and I can create recursion that allows me to either measure and optimize based on the sort of initial, which is basically going back in here, similar to what I did with the other benchmarking tool. I've got different approaches that can define, my structure, and the sort of output, and I can optimize that until I get the coherence that I'm looking for. Like it always gives me the same answer based on what I need it to be. So I can basically benchmark it and evaluate and optimize it, basically using almost exactly the same approach I use with the Spark benchmarking tool. It's a different implementation for different purposes, but conceptually I'm doing reinforcement on it.
Yeah.
And by the way, there's a really cool new feature I discovered. It's not new, but it's new to me. Live share. Have you guys seen this? You guys can log in and take a look at my my live running Git code space.
Oh, I can take control of your terminal right now.
Yeah, here I'm gonna let you guys do that. Share read-only terminal.
That's pretty funny.
All right.
RMRF.
We're gonna have 50 people hacking on your shell.
Here we go. Yeah, here we go. Let's do it. I'm gonna give you guys access. I'm gonna slap it in the code. There's nothing too worries. There we go. This one's the one. Let's see what I have here. Yeah.
This is just a feature of.
Actually, before I do, I'm gonna stop sharing just for a sec, guys. I'm gonna check my environmental variables before I do that.
Yeah.
It's all right. We're here.
Maybe later. Maybe later. We'll come back to that one. I'm like, how long has it been since Rue's been hacked? 24 hours. No. Anyway, how about next time I do a live coding session? I will share the session using that feature, and you guys will be able to log in and we can collectively fool around with the coding instance. or maybe maybe I'll just remove the environmental variables and we can do it a little later. But anyway, that's
We can do
what
code
I've been up
roulette.
to.
Just have code roulette. Get it. Whoever gets selected has to write a line, and we just keep going. Yeah.
Oh man,
Yeah.
peer coding.
Yeah.
Vibe peer coding en masse. That's awesome.
I know, right? It's so fun.
Write a line,
Yeah,
take a shot.
exactly. Oh, actually, you know what I'm gonna do? I'm going to share the one where I don't have any environmental variables I'm worried about. But we'll come back. We'll come back in the after show. We'll do some little collective vibe coding, or more like hacking Rube. Anyway,
The after party, man. That's where all the action is in the after party.
all right. I wanted to go 20 minutes, but somehow I managed to go a half an hour. So I'm gonna let Braun or whoever else we have going here take over.
Yeah, we thanks, Drew. Awesome. We should give Brad a moment here. He's got some updates for us, and then we'll bring in Willie V3. Brad?
Hey, thanks a lot. I'll be really quick. Big news is we're going to be updating our agentics.org website, especially the member services portion. So we're calling on anyone that wants to help out. We need tons of help. We want to make sure that we have an amazing site. So when you go in, you log in for your free account, paid account. We'll have the events, the different learning aspects, have these videos available, all the committee level information, chapter information. So it's a big project. Looking for anyone and everyone that wants to be involved. We're just starting the process, identifying different vendors that should be confirmed next week. We're all ready to go. I'll post the link in the website, and pre-thanks to everyone that wants to volunteer. Thank you.
And just a reminder, now that we have the free GitHub and code spaces, there's a benefit to you get some free GitHub access at the very least.
Mm-hmm.
And
Nice.
hopefully I think Martin said he's working on potentially getting substantial discount on Google related API and AI related tooling. So 75% off. Maybe we can do something there to get anyone that contributes access to those APIs as well. So you don't have to fork out your own money on that.
Go, Martin.
Yeah.
Do we
Would it
have
be possible
do we
to
have
form
Willie?
a company,
Oh, sorry.
form a company and get a company team access to Codex? Be a lot cheaper than individual
Yo,
$200 a month.
Mark, do you need me to
we-
hire you as an intern?
Actually, funny you mention that. That's one of the reasons why we created a nonprofit. Literally was for that reason. So by having a nonprofit, almost all these big companies, Amazons and Googles and whatever, all have nonprofit rates, which are sometimes free, but generally somewhere between 25 to 75% off. So we're leveraging our nonprofit status to get cheap AI. Right, that's the
We are legitimately
master plan.
pushing forward democratizing AI, right? So I don't want those entities to think that we're not serious about our mission. We very much are. It just happens to be that it also, the collective will benefit the mission that we're putting forward.
That's right.
All right.
Wonderful, wonderful. Okay, do we have Willie?
Hey guys, I'm here.
Hey, how are you?
Good. Thanks for letting me share, y'all. This is super cool to see what this is turning into. I just came in via a LinkedIn post, I don't know, what was it, 4 or 5 months ago, and it's super cool to just see how much this has grown and how much it's taken off. Very validating for my recent career choices. Anyways, guys. I did something over the last couple of weeks, kind of silly, not as really serious or groundbreaking and things, just fun for me. I've always been into music, and I just got into coding. So I learned that you can write music in Python code with MIDI, right? And I was like, hey, wait, if the AI can write code and the AI can execute code, all I have to do is have it play the MIDI for the file it makes afterwards, right? So I like totally vibe coded this, knowing nothing about like synthesizers or anything like that. And what it ended up doing was we used an SF2 file. Not sure if you guys know about this, but Fluid Synth is like a old school like Python synthesizer library. And what we do here, can you guys hear it?
No.
No.
No, I didn't share right. Hold on. I'll
Yeah,
share
if you go back, there's an option to share with audio.
Yeah. Okay, cool. All right, I'll replay that first. So what the agent does, real simply, is she takes your request, and then she starts writing like iterations of the song, right? So the basic one, I just pushed enter on it, and that'll give you like a basic sort of electronic upbeat music. So here's the first beat, lays down the drums for us. Everybody hears that?
Yeah.
We need a theme tune now.
Okay.
Digital Friday.
Okay, cool. So she threw down the drum beat for us. Now it's gonna take that same now it takes that same code. It looks at it and it's like, okay, I need to add another instrument layer on top of it. And it needs to like be cohesive. It needs to like, so you can imagine the amount of like prompting like I had to go through to like get this thing to do this right. So there's like there's the initial agent that writes the code. Then there's a validator agent that goes through and validates the code that the agent wrote for musical cohesiveness. Then it pushes it like through and it'll play the music for us. The second one usually takes a little bit longer to load. And if there's an error, if the code hits an error or something, it'll actually push it over to oh, here we go, guys. Right? Not bad. Cohesive.
No, we are not hearing.
You guys don't hear it?
No.
No,
The previous one.
understand. Yep.
Okay, here, I'll play this. So here was the second run for you guys.
Yeah, I did hear the first one. I'm not hearing the second one.
Okay, here's the second one.
Yeah.
Sing.
Right? Same song, right? Another layer of music on top of it. Another layer of instruments, kind of cool, right? Still vibing. It's a little bit longer. Right? It doubled the length of music with each time, right? That was a real fun thing for our non-deterministic AIs to figure out. But I'll give you a little peek into the prompting here, guys. I'm not black boxing it. It's open source. Y'all can go to it. I'll post the repo after this. But we've got an instrument list, right? And this has to follow, if you're using this SF2 thing, you have to look up Weeds GM3, right? And you have to learn their instrument list. Oh, we got another one. This is a banger. Wait, I'll play it for you guys after it's done playing locally. Actually, wait, maybe we can just play it.
You're creating waves as well. Can you use
Yeah,
stems?
yeah. So it turns the MIDI into a wave file. Let's say it's just almost done.
You just need to integrate Pro Logic, and you're now just get the AI to create every pop hit for Spotify.
Yeah, right. So it goes to, okay, so here's the third version, guys.
Wow.
All right, another layer on top of it. So yeah, that's like, that was my project this week. It works pretty good with O3. It's a lot of fun. And then this will just keep going. It'll just keep going and going and going. And then some improvements I want to make. I discovered this library called Sonic Pi. I don't know if anybody's ever heard of it before, but like some dope, like some really dope synthesizer sounds and stuff.
William,
Yeah.
please forgive me for asking. What was the bottom line theory on creating this? You said in the beginning, and please forgive me, I was distracted. You said you'd realized something, and that was the bottom line theory that led to all of this.
Yeah, I also said as a disclaimer that this was not a serious project. This was like a real creative thing. Like everybody knows.
Oh, that's
that, like,
okay. My toddler is dancing to
Yeah.
your music in the background.
Oh, okay, let's go. So yeah, no, I mean the idea was like I'm at work and my 9 to 5 and we're like really pushing for like AI adoption and all this stuff. So we put together a little crew of people to have a little agent contest, right? I lost because I couldn't get my MIDI agent up in time, but then I took it home and kept building it, right? I was like, hey, wait, if the AI like can run code and MIDI, you can write that in Python, then like theoretically, couldn't my agent sort of write a song for me and like be a sequencer and like sort of develop this musical thing? And
I
like
get it.
worked.
It's a relationship between MIDI and Python, correct?
Yeah. And that I could have the AI sort of do that for me, right? Like, because now it can run code like autonomously and execute it. So I was like, oh, well, I'm going to make it play music for me. Why not? Right. So
what did you use? Rue code? What did you use?
I primarily use Cursor. I'm just a big fan of Cursor. I keep a language agnostic system prompt sort of in the Cursor rules. I'm still a little old school on that. I haven't upgraded to all the other stuff, but and I utilize a lot of the custom modes in Cursor. So I'll make myself like a Python mode, a Streamlit mode, Next.js, all these different modes, and then yeah, just kind of vibe out like that.
Is the model picking the key and the progressions and everything?
Yeah, it picks everything. But you can tell it in the beginning that there's like a prompt. I clicked enter and it'll give you like the generic sort of style, which is just upbeat electronic music. It never makes it bad for me. That one's always good for demo. But you can flip it to classical. You can say, hey, play a jazz song in A minor. It actually does pretty decent with jazz because the drums are like, sort of like the same beat and the bass line is just, walking quarter notes. So it does pretty decent with jazz. It gets a little wonky with the soloing and stuff and syncopation, but
Well,
yeah.
we all say if it's not country, it's not music.
Yeah, I don't. Who said? Back in the '90s, I'm certainly aging myself for a moment, but back in the '90s, I used to be a trance DJ, like circa 1996, and my spot was like 4 a.m. when everyone was kind of drugged out and done for the night. My job is to come on stage and basically get everyone out of their ecstasy phase, blown out phase and do the big drop and get one going again. But anyway, this would have been amazing back then.
Thanks, guys. I appreciate it. It was like a silly thing. I thought you guys would appreciate it. So cool. I'll post the repo. Hey, thanks, David. David, the archivist, young blood.
Question.
Yeah.
Is LLM listening to the music or just working on the code and refining the code?
Originally, I said, hey, I need the AI to listen to the music, right? And I fiddle around trying to get the audio to pick up on the OpenAI API, like while so my speakers are playing music and the microphone listening doesn't work at the same time. I don't know if anybody else knows how to figure that out, but I could not figure it out. Every time that the music played, the microphone turned off. Like my system wouldn't let it happen.
Have you tried sending files?
Hmm?
Have you tried sending like exported files?
No, I didn't try sending the WAV file or anything. But dude, you guys are like super welcome to contribute. I would. That'd be super. Yeah.
My son vibed a interface for you. He was working on a very similar project that he wanted to create he wanted to create a sequencer that allowed him to play his guitar with a kind of band.
Yes.
Right? So
yes.
and what he did, he was using, I don't know what he used actually, but what he did is he allowed the system to listen and then it would synchronize to how he played because his beat was not constant. So it would basically, much like a band sort of changes its tempo as you're playing. He managed to do that, and he's got a whole little app that does that. I should get him to send it over.
Yeah, that sounds cool.
And William, this is unrelated, but you wrote in the chat you met with the folks at Longchain, and they want to get. Can you explain that a bit more?
Yeah, of course. So I'm out in New York, guys. I work, my 9 to 5 is at a company called JustWorks. We do like HR payroll and stuff, and we're doing some things with Langsmith internally. And Harrison Chase was in town, and they were, of course, trying to get us to, sign the contract. So they're like, "Hey, come have coffee with us," and Harrison's going to be there. And I was like, "Hey, I'm going too." So I asked, humbly, and I was like, they let me go. And I got to shoot the shit with Harrison. I told him about agentics.org, everything that we're doing. I said, hey, Google like sponsored the Agentics.org meetup out in London. They had a great turnout. I think it'd be a cool opportunity for you guys to kind of, get involved into the more, really lock yourselves into the grassroots, open source, nonprofit thing that, where real people are coding. I also asked him the question, somebody asked me to ask him where he thinks that OpenAI went wrong in their implementation of agents. And I also asked him how he felt about getting dissed in their documentation with the LangGraph thing. And he said that OpenAI is just a consumer company at this point. It's not really paying that much attention to them. It doesn't think that there's like a lot of like developer focus going into like the product and this. It's more so just like hype
I disagree. He's obviously not using the latest models.
Just he's defending himself too. So
yeah, so it's the third time this week I've heard that. Just a quick update. If you guys haven't seen the responses API and their integration with their tools and now the MCP integration directly within both the response and their agentic system.
Sick.
I'm using it all this week.
It's spectacular. Like anyone telling you that they're not paying attention to developers is not paying attention to OpenAI.
Let's go. So anyways, that's what he said. But so I also mentioned, so JustWorks, we are open to having like events here, like for this AI kind of thing. So I was thinking it would be dope to have, LangChain with the agentics.org have their New York meetup at the JustWorks office here. We got a great space for it. So I was trying to set that up.
We have folks in New York City.
Where they at?
Look at that.
So sorry, hang on about the background noise, my bad. Real quick, sharing a link, just you reminded me, Willie, of, and great stuff, by the way, and your new website updates, also pretty fly with the Bel Air theme on it. But there's a link here. There's a project somebody did, and they used an old library called Jitterbit. And what they did was they, programmed AI to talk to itself, and it started to create its own language. And so it's using like high frequency sound to allow AI to communicate, and it reparses the sound into, its own language, and it's able to have a conversation. And there's like a future application of this where AI is going to be able to communicate, interoperably within systems through, Internet of Things type technology, and your like microwave and fridge and computer and watch and phone are all going to be able to help you like get through your day. Like that's what's coming when people put this together. But this Jitterbit's kind of a preview to how it can use like, hypersonic frequencies to communicate. It's absolutely crazy.
That was like 6 months ago that thing came out, that Jitterbit came out, and it never really took off, but it was pretty impressive. Like
I think it took off silently.
Yeah, the demo I saw was when some guy was on his phone talking, and an AI answered, and he was like, he recognized that there were the two AIs talking, so they said, do you want to talk Jitter? And he was like, yeah, and so they just started talking.
Wasn't that a concept piece though? I didn't think it was real.
Yeah, it's real. There's code.
I think it's real.
Okay.
Oh, absolutely.
There's a link.
It's real, but it was a mock-up demo.
Yeah.
It's on GitHub.
It was concept.
All right, guys, we got a bit of backlog we gotta get through, but before we do, I see an old buddy of mine on the call, John Willis, who is like the godfather of DevOps. Hey, John, are you? Hopefully he's paying attention because I'm putting him on the spot here. You there? If he isn't, we'll have to come back to him. But it's always amazing the people we get on these calls, and the folks you don't actually see or hear are always sometimes the most interesting crew we get here. Hopefully, I'll ping John in here and see if I can get him.
You can't do audio right now.
Yeah. All right. I think we got Braun up next.
Yeah, that's
Rob.
right. Braun.
Yeah. All right. Let me see here. Screen share. Okay, desktop, this one here. All right. Okay, so I don't know if you guys have been following NVIDIA. If you haven't watched their last keynote, I'd go through it. Some pretty insane stuff. These guys are saying things like million parameter model on desktops. But NVIDIA is going hard, I guess, trying to sell hardware. So they're also working on models. And if you look at the current ASR leaderboard, their model is crushing everyone. This parakeet is at 6.5 word error rate, but its output is 30 to 100 times faster than anything I've ever seen. And if when you're coding, usually it's pretty hard to beat the cloud. So let me see, I got to move this out of the way. But, if I looked at, where is it here? So these are like the top current audio to transcript systems, DeepGram, OpenAI, Whisper. So right now I'm hosting that NVIDIA system on my own stack with commodity card RTX 3600. And this is like 40 to 300 times less expensive than the major tiers. And, their takeaway summary, 120 times RTF. And, their summary is pipeline currently enterprise grade accuracy, 2 orders of magnitude lower cost than any mainstream SaaS state of the art. So I took it and I got these clients that want to build a transcript system for medical dental. So here I'll fire up the recording and let me clear this. And let's see here. I'll try to get some text going. So, okay. All right. We are live testing the speed of speech to text with AI Hackerspace Friday, May 23rd. Let's see. This pipeline delivers enterprise grade accuracy at hundreds of times lower cost than any mainstream cloud with state-of-the-art speed on commodity hardware. I can even do timestamping. So this will do real-time timestamping. I can turn that on or off. So this at 6.5% error rate, that is super low, which means it's usable. And after this is done, you can combine your audio to make a wave. You can also go through transcript editing, so you can load up your old transcripts, take a look at them. These would be your audio. So when you talk, it's chunking it, it'll recombine it into these audio systems. So you can replay your text. And I'll do this thing can do 1 hour audio. So I took this podcast. Let's see here. I'll grab it. So this is a 1 hour podcast because I had another guy that wanted to do podcast summaries. So that's why I was kind of in this space. But we can do a live transcribe of a full hour of audio. You gotta remember, this is like a regular graphics card. This is RTX 3600. Okay, so we'll fire it up. And this is starting the processing. What I had to do is all the audio has to be converted to 16K mono. And so what it'll do is it'll convert it with FFmpeg, then it'll chunk it into 30-second chunks, and then it'll feed it into the LLM. So pretty soon you'll see the chunking starting up. That's how you can fit it into a commodity card. So we're at, what are we at here? 30 seconds. So this is you can see it's going at more than 1 chunk per second. So that's feeding, I don't know, 5 minutes every half second or something into this thing. So we're at 46. So hopefully we can break a minute. 54, 55, getting close. Okay, so there we did it. We did as a full hour podcast transcribe with timestamps in 1 minute.
Good.
And this machine cost me 30 cents an hour. So you can imagine I can do 120 hours of transcribing for 30 cents.
Cool.
So this is pretty insane. Like you take Llama or any of these regular models, and usually they're getting crushed by Claude or OpenAI. But that's why I'm saying, we got to pay attention to these guys, because these guys are building Star Center $200 billion data centers, and looks like they're saying, well, how do we get more people to buy NVIDIA? Well, let's make models that need hardware, right? So I don't know, if we're getting to trillion parameter model on a motherboard in the next year, I think we're getting pretty close to, AGI or whatever you want to call it. But if you are into speech to text, like I say, you can do a rundown with O3. This is pretty nuts. If you look at the costs, like these top ones would be like, $350 to $1,000 to do the same thing.
Right. As opposed to 30 cents.
Yeah, it's just it's almost free. Like it's like the surprising thing is the quality, right? At 6.5% word error rate, this is top level. Like I can't name one other open source commodity runs on your graphics card LLM that can totally wipe out the major players. Like that's the first time I've ever seen it. And usually I tried the Sesame. They only released like the 1B version of Sesame, and it sucked. Like it was terrible. Most of the things you try when you have a guy saying, here, try my model out, it's nowhere near enterprise grade. It's sort of proven. Yeah.
There's an interesting approach that I've been doing, and you guys probably can't hear it because I've got my noise canceling going on here, but if you were to step into my office right now, it sounds like a jet plane. And what I've been doing is I've been daisy chaining low cost mobile GPUs using the eGPU enclosures that I ordered from AliExpress in China. And then what I do is I connect that to my system using Thunderbolt, and I can basically run, I think it's 6 mobile GPUs in parallel independently of my core system. And I can get all kinds of crazy stuff out of it. And the fact that I could probably use not mobile GPUs, but mobile GPUs are cheap out of China. You can get them for like $50. And yeah, and then I just run those in parallel. But what Bron's showing was like a perfect sort of application for that kind of thing. If you're interested in that, in those types of structures here.
Pick their standard like 3600 GPU. Do you think that the performance you get at a higher price one would give you a higher performance, or is it better to daily?
No, I'm using the Snapdragon or whatever. It's the GPU you get in like an Android device, and it's dirt cheap. I can get them. I get them for less than $50, which is like $30 American. I'm using Canadian money.
Snapdragon's a Qualcomm chip.
Yeah, you get them super cheap out of China. And for most things, you just need parallel, right? So GPUs, they don't need to be really particularly powerful at this point. They just need to be parallelizable, right? I need to be able to send a bunch of things to it and get it done in sequence versus, my CPU is kind of bound by running Windows or Mac or whatever.
Can we share some actual product things like which GPU? Because I've been shopping around, right? And if you found what a reliable supply in China, I'd be up for it.
Yeah, I sent a link to the site. It's in the text chat. I just go to AliExpress. Now, someone told me I was telling this to someone else earlier this week in the United States. Apparently, there's like some kind of crazy tariff they slap on for Americans right now. So if it's $50, it'll end up being like $100 for you. But if you're outside of the US, it's definitely cheap.
Should make it cheaper for us if they can't.
Yeah,
that's right. That's right. Well, just before we wrap up for the main hour, guys, we've got Benza here. He's going to give us a little recap about the London, UK. And just a note for folks that are thinking they would like to establish a local chapter or have some local events, there's the agenix.org/ambassador page. That's got the form to become an ambassador. And there's the ambassadors channel in the Discord. And in there, all the key documents are pinned as well. So please feel free to put your hand up. There was over 60 originally, and then 30 have come through the process. There's a bunch of places around the world that are about to get started. So we welcome everybody to hop onto that. Benza, you've got some pictures and a review there of the big event you had at the
Yeah.
Google office in.
Yeah, I've got I'll be quick. It is a wonderful venue at Google, and we made a perfect teamwork with Monweep and Rocky and Mark and so on. So I'm going to share my screen. So, can you guys see it now?
Wait, the desktop.
Yes. Yeah.
Yeah, so this is the reception with Requesty co-founder Thibault. This is the building outside. It's a very nice area of London, very sunny and real summer afternoon. This is the prep before the event, and then Thibault is giving an intro. The room was very interesting. Mark sponsored us a roll up with the logo and the message. Then Ruth joined in via Zoom. That was cool as well. And then Chris had a very nice lecture, live teaching of Spark and other methods that he found useful, and people enjoyed it a lot. And we made the interviews as well. We're gonna publish them. So in this style, the one-to-one interviews with participants.
Wonderful.
Yeah, so lots of pictures, videos. It was incredible, like vibe and feeling to do this live. There are some learnings for other cities. We're gonna publish them.
That's cool.
Nice. That's awesome. Good job on that. I got several people reach out as well that said they learned a ton and it was a great time. So thank you, for putting all that together. Well, Chris.
Cool.
Yeah, I just wanted to share. Recently, I've built a 30 agent orchestration in root code that basically codes out anything you could dream of. And so what I've got it set with is building a better version of itself. And what that ends up being is a symbiotic coder. You can kind of think of Venom from Spider-Man. That's a symbiote, but instead of giving you superpowers, it turns you into a super coder. It talks to you, it teaches you, it guides you on top of being a coder. And I've been live streaming the thing building itself on YouTube. And so if you want to check out my YouTube channel or LinkedIn, I put some links in the chat. And
cool.
There's like 20 hours plus of it running so far. It's quite amazing.
Yeah. So let's, you have something to show us? Put you on the spot here.
Yeah, sure. I mean, I have it running right now.
Yeah, let's see it. I love your experiments. They're always so exciting.
Yeah. So it's got a shared memory system that that I used through the Superbase MCP. I kind of just set that up last night, but what it is building is actually a Neo4j knowledge graph. It's already built out the brain. That was like step one. And essentially it documents everything, right? The research sets up, testing documentation, high-level testing documentation, like architecture, like everything is documented out, and it can access all the documentation through the Superbase MCP tool. And this is a way of being able to share, like say a 50 plus million quote unquote synthesized context window amongst all 30 agents. And they can and the orchestrators then have access to this. And then the orchestrators, there's like 10 orchestrators, and they all have access to say like 20 workers. And these orchestrators then can use the documentation to be able to guide the workers very, very precisely with full context. And you can shift the entire orchestration. You can maneuver it in any way you want, because it follows a memory system and a document registry. And like for instance, it was it was coding this thing out, and then I was like, hey, let's see if we can make this more autonomous. You know, I had it do research on abstract goal understanding, creative problem solving, ethical reasoning, novel architecture design. And so then it did a complete shift, reworked the PRD, redid all the tests, and now it's getting this fully implemented into the system as well. You know, it's got like a GitHub deep researcher. It searched GitHub for templates, and that's how it pulled up its front end. It identified a front end that would be suitable. This is essentially an AI-powered IDE, but it's a coding symbiote is ultimately what the end goal is going to be.
You know what you should consider? I love what you're doing, by the way, but you know what you should consider just to save some money on your context window? Because all those MD files likely are going to be loaded, you know, into the context for, you know, it looks like you're using Brew, I think. If you switch to like SQLite or DuckDB, you can take all that data, stuff it into a SQLite, and then create a like a really small Python CLI or MCP that basically queries it, and then you don't have to parse all that, and it'll save you probably like 80%.
Yeah, I could, but I mean, this is just temporary because really it's just building a better version of itself. And the new version is being basically graphed out in Neo4j in like a multi-dimensional graph that graphs out functions, you know, like all the relationships between code and different languages, as well as, you know, everything that you're telling it gets graphed in and through like the multiple layers of the graph, through like cosine similarity and a bunch of other stuff. It basically brings it to life. And like, that's how it's like basically sentiment, or is going to be sentient, to be able to fully understand your code, identify security, tech debt, like everything.
Cool.
So,
and what model are you using these days?
I'm using, so for every part of my orchestration, I'm using Gemini, except the test writer and the coder. That's the Claude 4. Claude just bangs this stuff out of the park.
I know. Yeah.
Right?
Don't use Opus. Don't use it.
No, not
don't
doing
do
that.
it. Yeah.
No, don't doing that.
I spent
saw,
$300, so you don't have to.
Yeah, cool. Yeah.
Thank you, Rube.
But Gemini is cool because, you know, it can take all the context from all the documents and then, you know, use that context, the larger context window, to then issue the commands. And then you see like the tasks, and also, you know, the coder and everything is doing self-reflection. Everything is doing AI verifiable end results. Like, so it's being specifically told, you know, to self-reflect. And by AI verifiable end results, it means that like the end result is something that AI 100% knows. I've reached this point. There is no subjectivity in the entire 30 agent orchestration whatsoever. That is very important, so that there is never any miscommunication. And then it even tells the modes. It's like, okay, I need you to do this, do this, do this. This is the exact document where this is documented. These are the exact files where the issue is going on. Like, my workers have full context of every move they're making, right? It's like having the software developer giving full context, but my orchestration is able to just autonomously do that, right? It is the software developer, right? That's pretty much why it took 10 orchestrators to, yeah.
All right. We have Shep. And we'll have to come back to your sentient thing, I'm sure, but I'm not gonna touch that just yet. But Shep, how's it going?
It's going well. I have a couple things that I'm keen to share here. I know we've kind of been working on the AI Hacker League in the background for a while. It's been a minute since I checked in, but as part of my hunt for a CTO for Penumbra, I'm doing a like hyper agent Olympics, where it's basically a 1 hour challenge that is, you know, imagine Leet code, but for like an agentic engineer. So it's a timed challenge of like how much of this crazy agentic spec can you build? And it's like scored based on points and stuff. I'll bring up the Notion page really quickly so you guys can just see
Neat.
what that is. But I'm mentioning it because like it's this group, right? This is very much like our DNA thinking about this kind of thing. And also it could be an interesting application of like AI Hacker League collaboration. Let me see, can you guys see this? I will
Warming-
assume yes.
Just
It's
black.
warming. It's warming up. It'll take a sec.
Okay. Drum roll. If it takes too long, I'll just I'll give up and I'll talk to it.
I'm not sure why it seems to be taking
It might
a
just be
lot.
my computer.
Limited bandwidth, or
Yeah, I don't know. I'll talk you guys through it. Basically, it's got 4 components where, you know, you're building a specific like agent ecosystem called NeuroNexus. It's like a live agentic system that includes agent orchestration. So you implement a multi-agent system using your orchestration library of choice. You build a few different like design patterns, so planner, executor, orchestrator, tool, user. You have to demonstrate like an MCP integration, bonus points for incorporating A to A, agent to agent. There's a second section for knowledge and retrieval. So like build a knowledge graph and graph rag into it and a vector search. There's like multimodalities. So can you integrate more than one thing, like not just text? Can you incorporate vision? Can you incorporate audio? And kind of build out some demo pipelines for searching across different modalities. And then the last 2 are kind of like tool use. So building like a plugin system, like a dynamic plugin tool calling suite that you can hot swap tools in, and some personalization. So like build a memory graph into it. It's honestly like the full bag of things that you can do with agents. But I'm really, really keen to see, can someone actually build this thing, this crazy ass spec in 1 hour, and kind of try and build like an ELO score for it, right? We've got the lean AI leaderboards and like all these different leaderboards in AI. I feel like this is kind of a cool thing for agentic engineers to sort of try their hand at, try their system, right? Because we're all building our own sort of tweaks on these setups like Spark and PharoMind and, you know, the cursor agent. So yeah, I just thought I'd share that with you guys because it's kind of cool. And I would love to, you know, figure out how AI Hacker League fits into this too.
I think there's two opposing thoughts right now in terms of speed and output. You know, and as you guys know, a lot of times people hire me for an hour to build some crazy idea that they have, and that's all they get from me. And you know, so when all
hire
you
you
have
to do
is
the challenge, Ruben.
yeah, like they literally hired me to vibe code for an hour. Like I get this idea for a startup that I'm going to pitch a VC tomorrow on. I need you to build it for me in an hour. And I'm like, all right, let's do this. But to do an hour build means that I need to skip a lot of the upfront planning and structure, right? So when you look at Spark, it does a ton of documentation, phased implementation strategy, the sort of London School of test-driven development, which is essentially a test-driven scaffolding that basically allows for the tests to determine the architecture of the application. That allows me to run these things in what I call a long horizon, meaning that hours, or potentially the longest one I've done is about 36 hours. But they don't want me to run for 36 hours. So I do the inverse. I skip a lot of that and I go right to the sort of test-driven, excuse me, test-driven development, and then work from the top down. So yes, you could totally build that in an hour, but you're going to get to a sort of rudimentary, you know, test output. It really depends what you're building, but there's little, you know, the demo I gave you guys earlier of that fax system. You know, I was able, after I did the actual implementation of the plan and the structure, that literally took an hour. And when I ran SCC against it, they said it was $2.5 million worth of value, if you believe that crap.
Yeah, I think the testing phase obviously is like super important. And part of the challenge with hopping in the saddle with like a 1 hour challenge is you have to already be opinionated a little bit about how you'd like to approach it and like designate those things up front. You know, it's I think you have to have your mileage on the road to actually sit down and build something that's like effective in an hour system.
Yeah, exactly.
Can I have a quick question?
Oh, yeah, go ahead.
Yeah, so the speed, maybe in Europe is a little bit different, but you know, Claude 7 and now Claude 4, 3.7 and now 4 is a little bit slow. You know, you Shep, you mentioned an hour, and Rube also speaks about speed, but I'm at least personally on my side, I limited by time. You know, as the code is streaming, is extremely slow. There are you know, stop and go. How do you handle that?
Oh, well, if you're using Rue, just make sure let me you're talking probably Klein or Cursor, which is doing a sort of line by line writing. In Rue, make sure you turn this on. And I try all of my I kind of want to try other ones that are, but I can't find anything that's as good. But if you go in here into, where is it? So I keep match precision somewhere in this general ballpark. That speeds it up. But editing through diffs, this right here is the most important thing. So, and what I noticed with Sonnet 4, it's now able to do diffs that are. I did a diff earlier this morning that was 800 lines in a single go. So this is if anything else, other than like the orchestration capabilities, this is huge. Make sure that's on.
Cool, thanks.
And the precision. So the lower the precision, the larger the diff. So if you want to do like a 1500 line diff, pop that down to 80%.
Yeah.
And by the way, guys, there's 8 people currently logged in. Let's see. Oh, we can chat here. We should sort of figure out how to do some live coding with this approach. Maybe next week we could use this live option here to do like a collaborative vibe.
That'd be a real hackathon.
How do you open the chat window?
I just found it a second ago. Let's see here. Was it shared? No. Read only. I guess I'm in now. I can see what you guys are doing.
By the way, you may want to rotate that Composio link later.
Oh, I rotate it every day. Yeah.
A quick question on AliExpress. Do you only buy enclosures on AliExpress or graphics cards as well?
Oh, I buy the graphics card. The cheapest graphic card you can get is actually in a one of those desktop TV boxes you buy. You can buy like a TV box with Android 15, and inside of that comes a little Snapdragon. $25.
Okay, so I should look for a Snapdragons.
No, you should look for a what the hell they call it? Android TV box.
Okay.
And the great news is now that the US has banned China, you can get these things in like 3 days in Canada. Yeah, so the best thing ever for like AliExpress was when they stopped shipping to the US. It went from like 2 or 3 weeks to 2 or 3 days.
But will that give us a big enough RAM on the graphics card? Because Bron was saying like 20 gig. Or do you disagree?
Yeah, it depends what you're doing. It's like if you don't mind running parallel processes, you're gonna have to probably create you can vibe your own driver. Like, I'm building custom stuff.
One
right?
can, not necessarily I can, nor does that should be that my priority.
So it comes like for $36. I see here 8 gigs and 128 gigabytes of storage and a Snapdragon. Here, I just randomly found one while I was on the site. You can do all kinds of hacking with this stuff, and it's Android. It's literally just a mobile phone in a box.
Sure.
Like
those are good for like any cloud, but if you don't have NVIDIA CUDA, you can't do nothing with it. That's what I was saying. NVIDIA's only building stuff for their hardware, and they that's how they crushed AMD and everyone, because if you don't have CUDA, you can't run LLMs.
Yeah, you can. And
I mean, you could, but you can't run enterprise crushing LLMs with.
Well, you're not going to run
you're
not going to run the enterprise crushing on a $25 Android box.
Well,
so if you want to do what Bron was saying,
just to be clear,
right? But I want to do what Bron was saying. So what I'm looking for is a graphics card that meets that criteria.
Well, you'd have to go. I mean, I wouldn't buy one, Martin. I can show you how you could just borrow them from the cloud. You get them on Google, Amazon, anywhere. Okay. Like. You can get it. The 35 cents is basically the cost to rent the card. That's it. So that's how, because it'll be like if you want to rent a high-end graphics card, it's about, let's say, 150 a month. But you can rent them per minute, literally, or per hour, right?
Okay,
so,
well, I don't have enough load to justify purchasing it, but I'm happy to look at EG.
Yeah, well, okay, I'll put it up. I'll put up the API per minute API and give you an API, then you can run it. It costs nothing, and it'll just spin up the VM, fire up the app, and then run for 30 seconds and die. Yeah. Simple.
Perfect. Yeah.
Yeah, it's you guys. I'm just hacking for the sake of hacking. I'm not looking to, I just want to see if I can, throw out a daisy chain series of Android boxes that I can do various, tasks with. Like
Well,
there's no
those are cool.
reason.
Those are like the Raspberry Pi. All those small hardware boxes can do, like I used to use those for PCs. You can put Ubuntu on those or sometimes even Windows. And now you got a $25 desktop. 8 gigs is enough. I mean, I used to do that on 4 gig RAM boxes, and they could run Windows. So
Yeah, exactly. It's sometimes you're just doing stuff because you can. There's no real reason other than just to see what you can do. Scott, you got a comment?
Hey. Yeah, so I've been trying to do a lot of like automated builds, but like the one thing I keep running into is documentation is like usually behind where like if I'm like say, hey, I want to make an OpenAI calling app and it'll like try to use the wrong API. Do you guys have any like
Oh, yeah.
bulletproof ways to handle that? Because that's
Yes.
always limits my automated builds.
Context 7. Context 7 is probably the best MCP, bar none, for just massive amounts of up-to-date documentation. What I do, I use a combination of Context 7 and Perplexity. And then I just point at that and say, before I even start, I'm like, give me all the most up-to-date information on whatever API, SDK, or whatever. And then I point it at Context 7 and I say, go create a docs folder with everything I need to know, or whatever the API needs to know. And then I combine that with the other components, and then I let Spark or whatever I'm using go do its thing. Context 7.
And is that like pooling all the latest documentation, throwing them into like .md files for you, and then
here, let me
go
send you a
read
link.
that as you fly.
Yeah, it's spectacular.
Okay, cool. That's great. And then like for like stuff where it's like very specific, I guess ISO, like if you have like a very specific like scientific library that you need to throw in so you can do special stuff, can Context 7 do that too? Or is it worth just grabbing the docs themselves and throwing in there manually?
A lot of my projects are ridiculously complicated scientific work, right? A few weeks ago, I demoed that multiplexing 5G, ASIC chip thing. And now I'm working on a drug trial. There's no limit to the complexity. Yeah, it's you can do anything.
Pretty cool. Awesome. Thanks for that. I appreciate it.
Yep, Context 7 is the way to go. There's I think 12,000 different docs.
One caveat is pay attention to the version, or be specific about the version of the library you're using with Context 7.
Okay.
Yeah. Well, here's what I do. He brings up a really good point. Point Context 7 at your requirements.txt or your package.json or whatever, and say basically create the documentation based on that. Inversely, if you're vibing it and you're using like deep research or something, get it to suggest the most recent package and then point it at that.
You just ask it, hey, what's the latest?
Yeah, exactly. And if you're vibing, remember when you're vibing, it's likely going to vibe based on what it was trained on a year and a half ago. So when you add Context 7 or even Perplexity as part of your initial sort of research phase, it'll give you the most recent version. And a perfect example of that is when you are using like OpenAI, it has a tendency to give you the chat completion or chat completions plural, which is old, right? No one's building with chat completions unless you don't know what you're doing. If you're building right now, you're going to build responses because it's better, it's faster, it's got better tooling. But basically, it was invented after it was trained, so these language models don't even know that it exists.
Okay. Cool.
Yeah. All right, we're almost out of time, and I've got a hard stop at the bottom of the hour because nonstop calls today, one of those days. Anything else you guys want to cover? Any comments? Anyone want to? This is the open mic portion. We got a couple more minutes.
That's gonna be so fast. Okay, can I?
Yeah, go for it.
Okay, I just want to ask about what has been written in the WhatsApp about Claude with Sonnet plus Opus for not using the API, which is, you are confirming that Opus is so expensive. But I think there is a way that I think Pascal wrote it down in the WhatsApp to link Cloud Code with, with the Pro or Max account with Claude. You know something about this? How you can save it, and use
I've
Claude
done
Code.
that. It's definitely saved me a ton of money. I'm starting to hit rate limits now, but it's been absurd how much I can get away with just the $100 a month plan in Claude Code.
So it's that what Pascal wrote down, right? How to do it. You link like the two accounts and then you can use it and you save a lot, right?
Yeah, when you set up Claude Code for the first time, it'll ask you, do you want to use the API or do you want to hook it up to your account? But you do need one of the Max accounts to do that.
Okay, fine. Thanks a lot. I will
Yeah.
start now that it's confirmed.
And by the way, I did the same thing with the Codex project last week, and Codex is unlimited. So what I ended up doing was jumping back and forth between Codex and a sort of code space that was connected to the same GitHub. And then for certain things, I just get Codex to do it because it was cheaper, like run the tests or whatever. And I was able to greatly reduce my costs by having Codex do some of the grunt work. Now, certain things it's just better to get, kind of the Spark approach. But once you've got the root files in Codex, it kind of picks up on your preferred development methodology and kind of adopts the same general structure. Guy,
No, I was just gonna say, Joseph, if he knows what is the amount, like 2x or 4x, between using or not using it, how much is saving you? I mean, how percentage?
I just started using it this month, so I'll tell you at the end of this month. But,
All right,
again,
cool.
the drawback, right, is like I'm not using Klein or Rue, which, has a little more control over things. But I don't know. I've been really enjoying Claude Code. It's actually doing most of what I need to do. But if you're trying to do stuff like Ruv's doing, right, where you just like leave it and let it go forever, that's not what this is for. This is more for like refactoring existing things or kind of working on existing things, not like starting from scratch.
Yeah, which is what I'm doing. Yeah. Okay. Thanks a lot.
yeah, and keep in mind, I've got to a point after years of trial and error to be able to run things for 36 hours. Generally speaking, I'm not running for 36 hours, as I pointed out earlier. I'm running for a couple hours, maybe 3 hours, testing, fixing, adapting. If you're thinking you're going to run this for 36 hours and build the next biggest app ever, you're probably not. There's most things don't need to run more than about 3 hours.
Any thoughts
Guy,
on OpenAI's acquisition of Johnny Ive's company? Nope. All right.
Nothing positive.
It was such a nothing video. Like there was nothing that they said that was worthwhile in that video.
It reminds me of like my daughter and her best friend's video where they have little hearts coming out and it's a love fest. Okay, great. Good for you guys. I guess it's who you know. There, that's all I got. OpenAI is like a love-hate relationship. Generally they're freaking evil, but they do some really nice tech. I know to Willie's point earlier, they're doing some great stuff with their API, without question. But they're also doing some just bonker stuff with like their partnerships with the Middle East and government and stuff that really rubs me the wrong way. There, that's it. That's all I'm willing to say at this point before I end up in a foreign jail.
So just as a quick snippet, while it's there and before you close it, there's two files, actually three. Shep threw one up too, but there's two files that are tools that I've curated with AI. They're drafts. You can refactor them all you want, but basically just wanted a streamlined, unified way to, regardless of project, regardless of library, regardless of languages, etc., create a universal source of truth as a catalog of technology, libraries, versions that can be pointed to when prompting the AI to make sure we're going for the latest docs via Context 7 or other things. So those two files are simple little tools as file to insert to your repo that can help out with that.
Awesome.
All right. Oh, by the way, for all the people that are logged into that session, I only enable read only. Just as an FYI. All right. So next week, let's maybe on Thursday we can do a joint hacking session using the live options. See what we can collectively create together.
When is your O'Reilly?
Yeah, I should probably promote that. I think it's on the 29th. I'm doing a live data science session with O'Reilly next week, and it's pretty cool. I'm just going to show you how to do basically vibe data science, and I created. Some of the guys tuned in yesterday. You saw the presentation, and so there's a whole system I've devised to do that. If you're
Is
interested.
it in the afternoon? What's the time of it?
I have no idea. I'm a robot.
It's 11 Eastern. Well, that's the whole session starts at 11 Eastern, but Rube's just one of the speakers.
I think I'm middle of the pack. I think it's 3 hours. I'm a couple hours in or something.
I'll post it to the chat and also to Discord. So,
all right, gotta go, guys. I'm late for my next call. Thanks everyone again.
Thank you.
Highlight of the week. Thanks, Martin, Robert, everybody. All right, till next time.
Thank you. Bye.
Thank you. Bye.
Thank you.